everyone. I welcome you all to today's topic Decodified session. We are going to talk about the Small Satellite Launch Vehicle SSLV of India in this particular session. We shall be following this particular sequence. First of all, why it is in news, then about SSLV. We shall be understanding the orbit and followed by the practice questions for you all. Now, why it is in news? So, ISRO is going to launch its new SSLV rocket on maiden flight, that is first flight on August 7 from the launching station Sriharikota. My first question to you all, which you have to put in the comment box, is where lies Sriharikota launching station of ISRO? In which state? Now let's get to know about SSLV. So Dr. Somnath is credited with designing and developing the SSLV during his tenure as director of Vikram Sarabhai Space Centre in Thiruvananthapuram since 2018. It is a 3-stage launch vehicle configured with 3 solid propulsion stages and liquid propulsion based velocity trimming module VTM as a terminal stage. All 3 stages of the SSLV will be solid propulsion stages. The SSLV carry satellites weighing a maximum 500 kg to low orbit, while the PSLV can launch satellites weighing above 1000 kg. So PSLV is for lighter payloads up to 500 kg maximum. Key features of SSLV: low cost with low turnaround time, flexibility in accommodating multiple satellites, launch on demand feasibility, minimal launch infrastructure requirements, etc. So this one is basically very easy to use, very easy to put into application. This is the Small Satellite Launch Vehicle of India, which can launch on demand, as in India can cater to the international demands for launching various kinds of satellites and other sort of payloads which are up to 500 kg. Cost-effective launcher for small satellites in dedicated and ride-share mode. The aim of development of SSLV is to become more cost-effective in terms of a launch vehicle with a high launch frequency and a quick turnaround capability to cater to growing opportunities in the global launch services market for small satellites, to create greater synergy between the space sector and private Indian industries. Now let's know about the orbit. An orbit is a regular, repeating path that an object in space takes around another one. An object moving around a planet in an orbit is called a satellite, just like Moon is orbiting the Earth and the satellite of Earth. And there are many other satellites launched by various countries that are revolving around Earth and hence are in orbit of Earth. Anything that is in orbit of a planet would be known as or would be called as a satellite, and hence we call them satellites. One natural satellite we have, that is Moon, and other satellites are artificial. According to the height of the satellites from the Earth, the orbits can be classified as higher Earth orbit, medium Earth orbit and low Earth orbit. So let me tell you, SSLV is for low Earth orbit, but we shall be knowing about all of these orbits in detail. So there are following types of orbits: geostationary orbit, GEO, low Earth orbit, LEO, medium Earth orbit, MEO, and sunsynchronous orbit, SSO, geostationary transfer orbit, GTO. Now let's talk about them one by one. So geostationary Earth orbit, it is also called geosynchronous equatorial orbit. It is a low inclination orbit. It makes satellites placed in it appear stationary. Reason: they have an orbital period that is the same as the Earth's rotation period. Hence, satellite spacecraft returns to the same point in sky at the same time each day. So basically, if you look at it from Earth, if you could see it, it'll seem like it's never moving and it's stationary. That's why the name geostationary. Communication satellites are often placed in GEO. Reason is that if they keep moving, your networks may get interrupted. So although they move, but they move with the speed of Earth itself around the Earth, so it may seem always to be stationary. Reason is this makes it easy for the Earth antennas to track them without rotation. Otherwise, even the antennas would have to rotate to catch the signal of the satellite, but that's not required. The antennas can be at one place and the satellite just gets rotating. The geosatellites are directly overhead the Earth's equator. To an observer who is near to the pole, these will appear lower in the sky. Isro's Indian National Satellite System (INSAT) is placed in geostationary Earth orbit. It is one of the largest domestic communication satellite systems in Asia Pacific region. Now let's talk about the LEO. It is relatively closer to Earth's surface than the other orbits. The altitude from the Earth's surface could be between 160 km to 1000 km, and that range would be known as LEO. The satellites placed in LEO can have a tilted plane. It is one of the most commonly used orbits. Reason is that the satellites placed in it have more available routes as they don't have to follow a particular path around the Earth, just like GEO. It is used for satellite imaging. The images are of high resolution as orbit is closer to the surface of Earth. So the images captured from satellites in LEO are going to be more clearer. The International Space Station ISS uses lower Earth orbit. It makes travel of astronaut easier. So where lies the International Space Station? Orbits Earth in the LEO. It is used by remote sensing satellites. What is used by remote sensing satellites? Lower Earth orbit. Now let's talk about medium Earth orbit. The orbit altitude of which is between LEO and GEO is known as medium Earth orbit. It is also known as the intermediate circular orbit. It shares similarity with LEO as the MEO satellites too do not have to track the path along the Earth's equator. Navigation satellites and a number of artificial satellites are placed in medium Earth orbit. Global Positioning System, that is GPS, is placed in medium Earth orbit, that is 20,200 km from Earth. Communication satellites too can be placed here. Example, O3b MEO satellite constellation. And otherwise, where are communication satellites placed? In the GEO. Now let's talk about polar orbit and sun-synchronous orbit SSO. The SSO satellites travel past Earth from north to south instead of west to east. These pass roughly over the Earth's pole. The altitude can go as low as 200 km. However, mostly the satellites are placed between 600 to 800 km. As the name suggests, the SSO satellites are in synchrony with the sun, meaning the position is fixed relative to the sun. SSO satellites always visit the same spot at the same local time as they are sun synchronous. It is used for imaging, spying and weather satellites. Now let's talk about geostationary transfer orbit. I want you to pay attention towards the name and you will never forget it. The orbits are used by satellites to travel from one orbit to another orbit. So that's why transfer orbit, because satellites from this particular orbit can actually transfer to another orbit. It is a common transfer orbit between LEO and GSO, geostationary orbit. GTO provides satellites a halt, intermediate step before they can be placed in their destination orbit. This way it uses relatively less energy from built-in motors. The launchers do not have to directly place a satellite into GEO. Instead, it can first make use of geostationary transfer orbit. It is highly eccentric orbit, meaning the path is elliptical. What is elliptical path? Here is sun and this is the path that Earth follows. This is not absolute round path. So this shape of path is known as elliptical path. I hope you have understood the orbits and also about the SSLV. Now let me take you to the prelims practice question. With reference to the Indian Regional Navigation Satellite System IRNSS, consider the following statement. This is a previous year question. IRNSS has 3 satellites in geostationary and 4 satellites in geosynchronous orbit. Statement number 2, IRNSS covers entire India about 5,500 square kilometer beyond its borders. Third statement, India will have its own satellite navigation system with full global coverage by the middle of 2019. These are the 3 statements and you have to pick the correct answer from the given combinations. Option A, 1 only. Option B, 1 and 2 only. Option C, 2 and 3 only. And option D, none. So the answer for this particular question is A, that is 1 only. And now let's take you towards the mains practice question. Is low Earth orbit satellite best solution for satellite internet or not? Discuss. You need to answer this particular question in 250 words and send in your answers to us on WhatsApp to get them reviewed. This is it for today. I shall see you again tomorrow. Till then, take care and stay tuned.